Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we're at Norris Elementary School, home of the Squires, and we're here to do All right, today we're at Norris Elementary School. We've got some 6th grade students. You guys ready to go? Do you have any idea what you're going to do?
Math, kind of.
You can do some math. Perfect. That's all you need to know right now. Okay? So you have a couple of pieces of paper. One is a plain piece of paper. We're going to start with the graph paper first. All right? So go ahead and grab your pencils. And what I'd like you to do is just outline a square. And it doesn't matter where it is. Just outline a square. Now, what can you tell me about squares right now? What do we know about squares?
They have 4 sides.
They have 4 sides.
They're all equal.
They're all equal.
They all have right angles.
They all have right angles. Those are key things to remember about squares, okay? What I'd like you to do is close, but not touching. Outline another square. Now, are they the same or different?
They're the same.
They're the same, right? It's not turquoise, right? They're the same, right? You're like, hey, old man, they're the same. What are you talking about? Have you ever heard of the word congruent?
Yes.
You have any idea what that means, or you've just heard it?
Equal.
They're equal, right? If 2 shapes are congruent, they're the same shape and the same size. Are these congruent?
Yes.
Yes, they're the same shape and size. Now watch, if I do this, I have now made another square, haven't I? Mm-hmm. But is that congruent? No. Similar, but it's not congruent. It has to be the same shape, which it is, but same size also, okay? What I'd like you to do is I'd like you to draw 3 squares connected like this. Okay, and you can put the division lines between them so you can see that they're 3 separate squares. Okay? So we're not going to worry about the shape being congruent right now, okay? Is there any other way I could put 3 squares together that are touching? They have to be touching somehow. Is there another way we could draw that where the 3 of them are touching? They don't have to touch each other, see, because this one doesn't touch that one, right? Is there a way you can draw 3 squares again, different than that, where they're all touching? Go ahead and try it. Okay, so some of you did, instead of a horizontal, you did a vertical, which is fine. And then some of you did where you made kind of an L shape, right? You went like this, right? Because that's 3 again, isn't it? Okay? But they're not in the same as that, okay? Those are tetrominoes, okay? Think about tet, T-E-T, right? 3, all right? So now what we're going to do is we're going to try 4. What I want you to do is I want you to draw 4. The only thing with this, I drew mine, the way some of you are looking at it, vertically, okay? If I just go like this and draw 4 like that horizontally, that doesn't count as a different way, all right? You see how this was a different way than that with the 3? Mm-hmm. I want you to take the 4 and see how many different ways you can put 4 of these squares together. There's actually 5 ways to do it, so see if you can find a couple of them, all right? you want to share yours? So go ahead. And what was your name again?
Christopher.
Christopher. So if you were missing one, go ahead and take a look at Christopher's paper. So there are the 5 different ways, because it looks like you guys all came up with the same 4. And then there's one where you have 2 squares on top, and then the bottom 2 are just shifted over a little bit. And that's the 5th way right there. And we'll do a little bit more work with squares and the pentominoes coming up with the students at Norris Elementary. We're back at Norris Elementary School working with some 6th grade students and going to do some work with pentominoes again today after they learn the basics about the squares and congruency. All right? Have you ever worked with pentominoes? Anybody know what pentominoes are? All right. Well, you know what? Let's take a look at these. Have you ever worked with these? Some of you have, some of you haven't? All right. So here's what we're going to do. Each of you is going to get your own set of pentominoes. All right? So there's yours. And what I'll do is just pass them down and just make sure that the person next to you doesn't have the same color. That way they don't get mixed up. Let's see, we put another blue down there, right? You want a red, and let's see. Oh, that's it. We have a purple one in there. All right, so go ahead, take them out. Spread them out. You can just put the bags on the floor if you want next to you so that they're out of the way. Now, take a look at the different pentominoes. What do you notice about them?
They all have 5 squares.
They all have 5 squares. That's the key. All right, they all have 5 squares. All right. Now, some of your shapes may not have the little lines on it, but they do all count as 5 squares. All right. Here's what I'd like you to do. Just take a couple of them and put them together somehow, then see if you can make a little something. Just anything at all that you would like. You don't have to use all of them. You can use 2, 3, 4, whatever you like. Just put a couple of them together and see what you come up with. Kind of like puzzle pieces, huh? Seeing if you can fit them together and make something. So you guys see how they kind of fit together? Yeah. All right. And some you might have to turn or flip over in order to make it fit a little bit better. All right. Here's what I want you to do. On your plain white piece of paper, I want you to make a rectangle. But the rectangle has to be 3 by 5. Okay? So if I take this piece and I put it right here, I know I've got 1, 2, 3. Okay? And I've got 1, 2, 3. So how many more can I go down?
2.
2. And then I've got to fill all this in also. Right? So what I want you to do is I want you to see if you can make a rectangle using any combination of pieces that will make a 3 by 5. And you can just do it right on top of your white paper. And then if you get it, we'll trace it out and see what shapes you used. All right, so go ahead and try that. You've got a 3 by 5. So what 3 shapes did you use?
I used this piece,
Okay.
this piece, and this piece.
Okay. Now these pieces actually represent letters so that people can tell them apart sometimes. So look at the 3 pieces that you used again. Okay.
C, P, and Z, I believe.
That one's going to be classified as a Y. So if you kind of put it sideways a little bit, like tilt it, you see how it's a Y? Okay. So you have a C, right? And then the P, what else could it be besides a P if somebody wanted to make that a different letter?
D.
It could be a D or a B, right? So there's 3 different ways you could do that. And then that other one that's a little bit off, that's the Y. So by using those 3 shapes, you're able to make a 3x5 rectangle. And there's another way to do it, and we'll let the kids work on that as they continue at Norris Elementary School. All right, we've got 6th grade students at Norris Elementary School working with pentominoes, and time now for your next problem to do, okay? So we saw about how shapes can be congruent, right? They have to be the same shape, same size, right? And then those are congruent. We can see how you could use different pieces, different pentominoes to make the same dimensions, a 3x5. Now you're going to have to use a certain number of pentominoes. It could be different for every one of you, to fill in the shape that you receive. Are you ready? Are you sure you're ready? This is not going to be easy. This is very difficult. Do you think you have mastered the pentominoes?
Maybe.
All right, let's give it a shot. All right. You have 2 sides. You may choose which side you'd like to do. You have 2 sides. You may choose which side you'd like to do.
Okay.
Would you like the choice? Ooh, that looks like a difficult one, but it's up to you. All right? And these are just coming at it random. All right? Do you like that side? Or do you like that side? The choice is yours. That's too easy. You better do that side. Oh, and look at this. That's too easy. You better do that side. All right. You have your challenge. You have your 12 pieces. Start going ahead, work on those, see if you can make those pentominoes fit in your designated area. You think you'll get it the first time? Probably not, right? But they'll all fit. Some will use all 12. Some may only need a few. And that's not the bell for you guys to be finished yet. You have more time. All right, good. So you've completed yours. Nicely done. How many pieces do you need?
3.
3. That was an easy one, right? Be done with that. Now let's do that side. And remember, they have to fit perfectly. You can't have any overlapping, none going outside of the figure, and no empty spaces. Nicely done. This is going by the wayside now. Try that side. Oh, here's your pencil later on. That's a difficult one, isn't it? Right? Because you've got those shaded areas right there. If you want to, after a little while, if you get too frustrated with one side, all of you, if you're like, you know what, I just can't get this one right now, you can flip over the other side and try that one also. But see, this is a different type of math, right? Because you guys aren't adding, subtracting, multiplying, and dividing numbers right now. You're working with shapes. When you're working with shapes, what area of math would this be? Do you guys know? Like if you're working with squares, rectangles, circles, triangles. Have you guys ever heard of geometry? Oh, yeah. So this is a little something you would do during that. Oh, there we go. Nicely done. There you go. Perfect. All right, you want to try the other side now? Why not? All right, and there we go. We've got students at Norris Elementary School, 6th grade, working with pentominoes and an introduction to geometry. Once again, we're at Norris Elementary School, working with some 6th grade students, and our final activity with pentominoes today. So you've got one game board between the two of you. What do you notice about the game board as far as pieces or shape or anything like that?
They're all squares.
They're all squares.
And all of these can fit on there, I believe.
Right, those pieces will fit on there.
It's 8 by 8.
It's 8 by 8, so it's a lot of little squares making one big square. If it's an 8 by 8, how many pieces are there?
64.
So it's 64, right? That's the total area, right? If we said it was a square inch for each one of these, it would be 64 square inches, right? Here's one. We'll just throw this in as a bonus question for you today. Now you just figured out it's an 8 by 8. What's the perimeter of this game board? If it's 8 by 8, what's the perimeter?
32.
32, right? You just add up all the sides going around, right? That was just an added throw-in right there. All right, you guys ready? Yeah. All right, here's what we're going to do. You have a set of pentominoes between the two of you, all right? You are going to set any pentomino you want anywhere on the paper. Your goal is to block the other person from setting one down. Okay? So if you put one and you do this, all right, you obviously can take a pentomino and put it anywhere you like. All right? So you want to be the person to block his move, right? If he can't go, you win. You get it? Mm-hmm. All right? Now you place them anywhere you want, whatever ones you want. If she can't go, you win. You guys ready? All right? So, the person sitting on the left of the game board will go first. Let the games begin. Go. So we've got a winner here. Who won there? You did? You did? Okay, clear the board. Now we're going to do this. This is going to be different. You're going to need your pencil. Okay, each person is going to need a pencil. What you're going to do is you're going to take the numbers 1 through 16, all right, and you're going to write them anywhere you want. Okay, like if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, wherever you want, write 1 through 16. All right, go. One person start. So you write 1 through 16 quickly, any squares you want. They don't have to be in any order. You just randomly put 1 through 16. Spread them out. Now, you girls have 1 through 16 all written down? Okay, do it again. Once you get 1 through 16 finished, write them down again, someplace different. 1 through 16 again. Here's what you're going to do now. Now, you may take any piece you want, but instead of worrying about blocking the other person, wherever you put your piece, whatever numbers they cover up, that's your score. Get it? So if I have this piece and I go like this, that's covering up a lot of numbers, isn't it? and they're all pretty high numbers. If I went like this, I could do that, but now I've only got a 3 and a 4. I would only get 7 points for putting it there. Otherwise, if I did that, I would get a lot more points, right? So after you put your piece down, take it away, count up the number of points, write it on your paper. Whoever has the most points at the end is what?
Winner.
The winner. You guys ready? You can't use this one first, though. Whoever goes first. The person on the right goes first this time. Okay? Go! How could you make this game more difficult or easier?
You could put more numbers.
You could put what?
Put more numbers.
Right, we could put more numbers because if there's 64, we've only used 32 of the spaces right now, right? So you could do 1 through 16 again and then do it again. So every square has a number on it, 1 through 16. So you would be writing down every one of those 4 times. So then you would then have to think about, all right, we don't have any empty spots to worry about. How could I get the most points and block the opponent also at the same time? So that's yours now. So it looks like you've got a 13, an 11, and a 12. That's a nice one to put right there, huh? All right. You guys all have the hang of this one? All right, keep going for a few more minutes. Those are the 6th grade students at Norris Elementary working with the pentominoes and a few strategies to add and block. Beautifully made. A perfect fit?
Yep.
All right. Specially designed just for you. Oh, that was weak. There's no cheer.